Everyone, here today uh, I have come up with the 2024, so today's exam, Neet exam, and one by one I will say the answer keys, and with along with that I will provide the hints or the solution as much as possible. So let's start. So the first question is the compound that will undergo SN1 reaction with the fastest rate. So the SN1 reaction, in case of SN1 reaction, the stability of carbocation is the most important factor. So carbocation stability is the most important here. So if you consider the first option here, the carbocation will be generated at this point. So this is 2 degree in nature. This is a carbocation which is unstable phenyl cation. This is a carbocation which is 1 degree in nature carbocation, and this carbocation is a benzyl carbocation which is this adjacent position of benzene group. So the most stable carbocation is option 3, and the answer is also option 3 because it is the most stable carbocation, and in case of SN1 reaction, which has the most stable carbocation will undergo the fastest SN1 reaction. So option 3 is the answer. Question number 51 of question number 51. Let's move to the second question, that is 52. Now it is said here that the highest number of helium atoms in it. Okay, so now you know that in case of 1 mole of a compound or atom, it contains Avogadro number of atoms or molecules, like Na 6.022 into 10 to the power 23. Okay, so now the highest number of helium atom is, so the mass of helium atom is 4. So here let starts with the option 2. 4 gram helium means 1 mole, and in option 4 it is said that 4 mole. So 4 mole will contain 4 into Na, that is Avogadro number of molecules. So obviously option 2 could not be the answer. And if you consider the option 3, it is the amount that is in volume 2.27 liter. So if you divide it with 22.4 liter, then it comes out to be just nearest to the 0.1 mole, and it is not even equal to the option 2. So it could not be answer. And in case of 4U, that is 4 AMU unit, so helium is very low in mass, so it is not also the answer. So 4 mole should be the answer because 4 mole will contain 4 Na or 4 into 6.022 into 10 to the power 23 number of molecules. Okay, let's move to the 53, question number 53. In question number 53, it is said that in which of the following processes entropy will increase. So in case of entropy in a reaction, you have to calculate the delta n value. If delta n, or the number of change of molecules or atoms, will be positive, then entropy change will be more, that is entropy will increase. Now in case of a liquid evaporates to vapor, so vapor is more chaos and more movement of molecules is there in vapor, so it is the case where entropy increases. But in the option B, that temperature of a crystalline solid lowered from 130 Kelvin to 0 Kelvin, so it is cooled up. So if something is cooling up, so that should not increase the entropy of the process, so it is not the answer. In case of C, it is in reactant side molecules are 2, and in product side the molecules are 3. So 3 minus 2 is equal to 1. So delta n is positive. So here entropy also increases. In option D, so the product side is the 2, and the reactant side is 1. So delta n, or change in the number of atoms, is 2 minus 1 is equal to 1. This is also positive. So D will also be the answer. So in option 3, A, C, D is the answer. So here option 2 should be the answer. Okay, so some mismatches may occur with the official answer key, so this is according to me the probable answer. Okay, now in the 54 question, it is said that intramolecular hydrogen bonding is present in. So in this case, intramolecular hydrogen bonding in present in which compound? So intramolecular, it is said that intramolecular. So if you consider all the options, then a case of proximity or closeness will come into account. If you consider HF, then it will obviously hydrogen bonded, but it is not intra type, it is inter type hydrogen bonding. So this is what? This is intermolecular, inter. So different molecules are there, so this could not be answer. And here it is also hydrogen bonded but with the another same type of molecule, so this is also inter, not intra. And here in this case also it is inter, so the option should be 4, because here NO2 double bonded O minus will be hydrogen bonded with the OH fraction like this in a same molecule. So this is the answer. Okay, so let's move to the next question. So here it is said that the energy of an electron in the ground state is this is n equal to 1 of helium plus is minus x joule, and then for that for the electron in n equal to 2 for the beryllium 3 plus. So we know that energy expression in terms of many values, but in terms of joule values it is minus 13 point, should be z square by n square. So if it is said that z square by n square value, so z square value for the helium is 2 square, that is 4 divided by 1 square, and in case of energy of beryllium 3 plus, it is minus 13.6 into so it has 4 electrons, so 4 square divided by 2 square because of n equal to 2. So if you divide this 2, then this will cancel out, and if you compare this, this is like 2 square divided by 1 square into 2 square will be up and 4 square will be below. So this is 16, and above this is also 16, so 1. So the energy of beryllium 3 plus will also equal to minus x, so the answer should be option 4. Okay, so this is a haphazard thing, but you can calculate this. Thank you. So option 4 is the answer over here, and I can erase this. Okay, now move to the next question. If you move to the next question, you will get that E0 value for the Mn3 plus and Mn2 plus is given, and it is said that couple is more positive, so the reduction potential, it is reduction potential because plus 3 to plus 2 is happening, couple is more positive than chromium 3 plus chromium 2 plus or iron 3 plus iron 2 plus due to change of. So you have to just calculate or understand the configuration. So for normal manganese, so it has 25 of electrons, atomic number is 25, so argon, and 3d4s is the configuration, so 4s2, argon 18, 4s2, so total 20, and here 3d5. Okay, so if it become Mn3 plus, so it will be like argon and 3 electron will be less, and 3 electron, if 3 electron is less, then it is 3d4 and 4s2 0, 4s0, and for manganese 2 plus it will be manganese 2 plus, it will be argon and 3d 3d5 4s0. Okay, so in case when this is from plus 3 to plus 2, so the configuration is changing from d4 to d5. Okay, so configuration is changing from d4 to d5, so option 2 is the answer. But why? Because in case of d5 the configuration is fully not fully, this is half filled configuration, so half filled is more stable compared to the partially filled d orbital, so answer is option 2. Okay, so this is the answer of option 56, and let's move to the next question. So here in this question in 57 it is said that a compound with the molecular formula C6H14 has two tertiary carbon. It is very important. So IUPAC name will be. So in this compound you have to firstly calculate the DBE or double bond equivalent. So that equal to number of carbon atom is equal to 6, number of hydrogen atom is equal to 14 divided by 2 plus of 1. So 6 minus 7 plus 1 is equal to ultimately 7 minus 7, so 0. So no double bond equivalent. That means there will be no double bond or like that, or triple bond. Okay, so this is alkane, normal alkane, but it has two tertiary carbon. So let's say carbon, and carbon, this is 4. Here also a carbon will be attached, and here also a carbon is attached. So if you fill with the hydrogens, so here one hydrogen comes, here CH3, and above this CH3 will come, here one hydrogen, and at the terminal end, at the terminal the CH3 group will be attached. So this is nothing but the 2,3 dimethyl butane. So the option 2 is the answer over here. Okay, let's move the option to the option question 58. So just zoom in to see it better. So in the question it is said that a given statement and statement 1 and 2 is given. So the boiling point of the three isomeric pentanes, N-pentane, isopentane and neopentane are given. So you know that van der Waals force will increase in case of non-branching. So if it something is branched, so that will have lower van der Waals force of attraction, in case of branching molecule. Okay, so here N-pentane will have the lesser branching, so normal pentane, then isopentane will some extent of branching, and neopentane will have maximum branching. So branching will increase and the boiling point will decrease. So option or statement 1 is correct. Now the statement 2 said that when branching increases, the molecule attains a shape of sphere. Okay, spherical shape will be attained by the molecule. This results in a smaller surface area for contact, due to which the intermolecular forces of spherical molecules are weak, thereby lowering the boiling point, and it is actually the van der Waals force of attraction which is said. So in this case, both statements should be correct. So the option B will be the correct option, because statement 1 is correct and statement 2 is incorrect. No, option not B. So option 1 is correct. Statement 1 and statement 2 are option 4 will be correct. Both statement 1 and statement 2 are correct. Okay, now move to 59. So here it is said that some conversion is there. So what will be the suitable reagent for this transformation? So it is just you can say that BH3, or that is diborane, it is actually B2H6 which is applied, and if you apply this, here OH will be there and here H will be attached, and after that further if you treat with the KMNO4, this is oxidizing agent, so that will make the OH group CHO, and it will be the answer. So option 2 should be the answer over here. Okay, so here you can see the question which said that which plot of ln k versus 1 by t is consistent with the Arrhenius equation. In my channel, that is Electron Cloud, I have taught you about the Arrhenius equation. So in Arrhenius equation, it is said that k is equal to a into e to the power minus ea by rt. If you take the ln, then ln k will become ln a plus of minus of ea by rt, because ln will cancel out the e exponential function. So if you consider this, that ln k versus 1 by t, so this fraction 1 by t, then it will be the decreasing curve. So decreasing curve, and 1 by t is the x terminal and y terminal is the ln k. So the option 3 should be the correct answer. All the other options are increasing plot and option 3 is decreasing plot. So option 3 is the answer. Now move to the Now move to the question 61. Let me zoom in first. So in this question, the question is very easy, that it is said that which is the most stable carbocation among the following. So stability of carbocation depends on the degree. If degree increases, the stability will increases. 3 degree is greater than 2 degree is greater than 1 degree in terms of stability of carbocation. In case of this is actually 2 degree, because it is attached to the other carbon atom, which is in 2 in number. Okay, so this is primary carbocation because it is directly attached to only single carbon. So this is 1 degree, this is also 1 2 3, so this is 3 degree, and this is also 2 degree. So 3 degree is the most stable, so option 3 is the answer over here. So next, move to the question 62. Here it is said that match from list 1 to the list 2. So let's see what is the options are there, what the options are there. So first option is the isothermal process, then isochoric. So in case of isochoric, there will be no change in volume, so constant volume. So it is option 3, obviously B is 3. So B is 3 in option 3 and option 4, both could be possible answers. Okay, so isobaric change is the pressure constancy. So pressure is constant in case of isobaric. So C is the 4. So C is 4 in option 3. So option 4 could not be answer. So option 3 is the answer over here. So you need not to match all the options if you are sure that one or two options are correctly matched. Isothermal process, let's see for your satisfaction. Isothermal process is the constancy of temperature. So A will be 2. So option 3 is correct in terms of that. And adiabatic process is the no change in heat. So option E for the D. So D is 1. So this is the correct answer. Okay, let's move to the next question. So this page is over as well. So let's move to the next page. So here it is said that the type of isomers are there, and you have to say and match the what type of isomers are there. So in the first case, it is the something, it is that it can be coordinate with the nitrogen atom either or oxygen atom. So this is a bidentate ligand type. So this is nothing but the linkage isomer. So linking is different in other isomers. So that is the linkage isomer. So A2. So A2 in option 3 and option 4. Now in this option D, let's say in D this is water. So water is just related to the solvate isomerism. Solvate isomerism is D1. So D1 in both cases 3 and 4. So this cannot help to reach in conclusion. So here in this case it is like coordinations. Option C is the most easy. So this is coordination. So C option will be 4. So C is 4 in option 4. So option 4 is the correct answer. Option 3 is the wrong answer. So let's move to the next example. So here it is a calculation type of thing, but it is not that much difficult. So it is said that 1 gram of sodium hydroxide is treated with 25 ml of 0.75 molar HCl solution. The mass of sodium hydroxide left, that is remained, is equal to. So it is basically NaOH reacted with HCl, and it will form obviously NaCl plus H2O. So this is nothing but the neutralization reaction. So this is initially 1 gram, and HCl is given that 0.75 molar. Okay, so the mole of HCl here is 0.75 mole. So 1000 contains 0.75. So divided by 1000. So 25 ml, 1000 ml contain 0.75 molar because of the definition of the molarity. So 25 ml will contain. So divided by this. So this will be 40. So 0.75 by 40 is the mole of HCl. Okay. So now if you calculate this, that 1 gram of NaOH was there, and after that if you calculate this, that that the number of moles will be similar, because in neutralization reaction both the A and B should be same to form C. Now mole of NaOH is what? Mole of NaOH is equal to N NaOH, that is mole of NaOH is equal to mole of HCl, that is nothing but NaCl. So NaCl is equal to what? 0.75 divided by 40. Okay, and mole of NaOH is 1 gram given mass divided by, sorry, it is not 1 gram, it will have to calculate W, let's say W divided by the molar mass of NaOH is equal to 40. So divided by 40 over here. Now 40 will cancel out. So you can see that calculation will be easier, must be easier, because they have calculated earlier, the question makers, to simplify the thing. So W is equal to 0.75 and 0.75 gram. So the 0.75 gram will not be answer. So if you answer 750 milligram, that will not correct, because it is asked that what is the rest amount or unreacted amount. So that will be 1 gram of NaOH minus 0.75 gram is equal to 0.25 gram, and it is multiplied by 1000 to make it milligram. So 250 milligram is the answer. I think it is option A. Okay, let's move to the next question. So in 66 it is said that for the reaction 2A is equal to B plus C, Kc is given, and at a given temperature the concentration of the reaction mixture is given 2 into 10 to the power minus 3. Okay, so then the following is backward reaction, or it will undergo backward or forward reaction. From the options we can easily say that. So for this we have to just calculate that the quotient of the reaction is what. If you calculate this, the quotient of the reaction, and compare it with the equilibrium constant, you can say that in case of Q, or reaction quotient is equal to concentration of B, that is product, into concentration of C divided by concentration of A and square. So is equal to concentration of B is 2 into 10 to the power minus 3, C is 2 into 10 to the power minus 3, and divided by 4 into 10 to the power minus 6, because it is square. Okay, if you calculate this, you will get that this will cancel out, and Q is equal to 1. Now if you compare with Kc, obviously Kc will be lower than Q. So if Q is greater than, then you have to decrease the concentration of the product, because product is in denominator. So to decrease the concentration of product, you have to do the reaction in backward side. The reaction has a tendency to go in backward direction, so option 2 should be the correct answer. Okay, this page is also over. Now move to the next page. So in the question number 67, it is said that match the options with the column 1 with the column 2, the list 1 with the list 2. So NH3 is given. So NH3 is actually if you properly prepare yourself, then you can answer it by just watching this. Not you have to draw the structure as well. So NH3 is the trigonal pyramidal. So NH3 is option A. So A is option 1 and option 4 is the answer, because other options you have need not to just calculate. So SF6 octahedral, let's see other options. D is 3. So D is 3 over option 4. Okay, then XC of 4 is square planar. So C is 2 over here, and B is 4. Let's say B is 4, so that is square pyramidal. So the B4 as BR here, and at the 4 side there will be 4 fluorine, and at the above side 1 fluorine will be there. So this is square pyramidal. So the option 4 is the correct answer. Let's move to the second option. So I think the next next question is not a question of Neet. This is a question of competitive exam. It comes in normal group D exams. So on heating, some solid substance change from solid to vapor state without passing through liquid state. Okay, so something that is heated, so solid something that is heated is directly converting to the vapor state. So you don't have to study all the question paper, total question paper. Just from this you can mark that this is a sublimation process. Okay, so the technique is used for the application of solid substances based on the above principle is known as sublimation. Okay, so let's move to the next question. Now here it is said that in the options here said that it is said that it is said that in which of the following equilibrium Kp and Kc are not equal. So Kp is equal to Kc into RT to the power del n. So in case of a reaction where del n is equal to 0, there only the Kp and Kc will be equal. Now calculate here 2 minus 2 is equal to del n is equal to 0. So this is equal, so this is not answer. Here also, here 2 minus 2, so it is not answer. Option 3 is just 2 minus 2 0, this is not answer. So PCl5 to PCl3 plus Cl2, so 2 minus 1 is equal to 1, so option 4 is the answer, because there the value of del n is not equal to 0. Okay, let's move the next question. Okay, here it is said that among group 16 elements which does not show oxidation state, -2 oxidation state. Okay, so here oxygen, selenium, polonium, tellurium. So this is oxygen, sulfur, selenium, tellurium, polonium. This is the 16 group 16 elements. So in these elements, if you move from the top to bottom, the electronegativity value will decrease. So if electronegativity value will decrease, then -2 or acceptance of electron will not be favorable. So in case of polonium, it is not favorable, so option 3 is the answer. Let's move to the, because that has the lowest electronegativity. Okay, now given statements of statement 1, the boiling point of the hydrides of group 16 elements has the sequence. So it has the water maximum and others are like tellurium, selenium and sulfur. So that is the oxygen, sulfur, selenium, tellurium, polonium. So the previous question will help you to solve these questions as well. So here in the H2O case, because it will form the hydride of oxygen, which is H2O, and hydride of sulfur is H2OS. So if you think that here hydrogen bonding will occur, so it will have the highest boiling point. But other, if you think that from this side to the lower or the bottom side, this has the van der Waals force of attraction, so the size will increase and the van der Waals force of attraction will increase. So tellurium will have the highest, then selenium, then sulfur. So this is the correct sequence. But what is the statement 2? On the basis of the molecular mass of H2O expected to have the lower boiling point, the other members of the group, okay, but due to the presence of the extensive hydrogen bonding in water, so it has the higher boiling point. So both statements are correct. So both statement 1 and 2 are correct. So option 4 is the correct answer over here. Let's move to the